Hey everybody, today we're going to continue our quadratics unit by looking at some different representations of functions and being able to pick out which one is a quadratic, which one is a linear function, and which one is an exponential function. We're going to identify them from two different ways. We're going to identify them from a function table and then from the equation. This should be a pretty easy section for you, and I'll talk more about the assignment on Canvas in just a minute. So for examples 1, 2, and 3, I have some function tables up there. We're going to look at some characteristics of each one of these tables that will help us decide which kind of function it is, linear, exponential, quadratic, or in some cases neither. So in number 1, what you need to look at is the pattern for the y values. So I have x and f of x. Remember, f of x is the same thing as y. So we're going to look at what happens when you go from one term to the next. So from 5 to 8, that is adding 3. From 8 to 11, that is adding 3. From 11 to 14, that is adding 3. And from 14 to 17, that is adding 3. We've done these a lot. The answer to this is a linear function. And it is a linear function because there is a common difference. And that common difference is adding 3 each time. So remember, in class, when we would look at these, we would decide, are you adding or subtracting the same value each step to get to the next term? And if that's the case, it's linear. We could write this as y equals mx plus b. All right, number 2, this is also an example you should be familiar with, although it's been a while since we've done these. Hopefully this will kind of come back to you. So if you look at what's happening in the y values to go from 2 to 6 and 6 to 18, I can tell right away that's not going to be an addition or subtraction, but what I actually can see is there is a multiplication pattern this time. So each time you get to the next y value in the sequence, that's not actually a sequence, it's just a pattern, you're going to be multiplying by 3. So if there's a common multiplying pattern or a common ratio, we know that this is exponential. It's exponential because in this example there is a common ratio, and all that means is there's a common number that we're multiplying by each time, and that common ratio happens to be also 3. They're not always going to be 3, it just happens to be that way in this case. So I want you to look at what happens in number 3. If you look at number 3, first I'm going to see if there's a common addition pattern. So if I go from -3 to 0, that's adding 3. If I go from 0 to 5, that's adding 5. If I go from 5 to 12, that's adding 7. So that's not a common difference. In other words, I know this is not going to be linear, and I'm definitely not multiplying here, so I know it's not going to be exponential. So I want you to see what happens in this one. You may start to see a pattern. Even though I'm not adding the same things, these numbers are going up. It seems to be kind of like the same pattern. So you can kind of guess, if I go 3, 5, 7, I bet the common difference here is going to be 9, which it is, or the difference to go from 12 to 21. The next difference would be 11, and the next difference would be 13. So I'm not adding the same thing each time, but I do see a pattern here. Now, this is going to actually come out to be a quadratic, and here's why. You look at something called the second difference. So this is a new term. Whoops, sorry. Here's what the second difference means. There's not a common first difference, but if you look at the second difference, what do you do to go from 3 to 5? You add 2. What do you do to go from 5 to 7? You add 2. 7 to 9 is add 2. 9 to 11 is add 2. And 11 to 13 is add 2. So to identify a quadratic function from a table, it's not the first difference that you're going to see the pattern. Well, you actually kind of see the pattern, but the second difference has to be the exact same amount. So this is a quadratic. And the reason I know it's a quadratic is because there's the same second difference. So you have to kind of take it a step further just to make sure and see that that's what's going on, okay? We're going to do one more example of a table that's a quadratic just so you can see what's going on. So in number 4, if I go from -9 to 0, 0 to 11, 11 to 24, etc., I know I'm not adding the same thing every time. So I can go ahead and rule out linear. I also know I'm not going to be multiplying by the same thing every time, so I can also rule out exponential. So what I'm going to see is if this comes out to be a quadratic. To go from -9 to 0, that is adding 9. To go from 0 to 11, that's adding 11. 11 to 24 is adding 13. This would be adding 15, and this would be adding 17. So I'm going to check out the second difference. So I'm going to take that another step, and I know to go from 9 to 11 is adding 2. 11 to 13 is adding 2. 13 to 15 is adding 2, and 15 to 17 is adding 2. So I can definitely say this is a quadratic because the second difference is the same value. All right, so that's from a table. So let's look and see some identifying characteristics from an equation where we can decide if it's linear, exponential, or quadratic. So remember, the basic form for a linear function is y equals mx plus b. I'm sure you are as tired of hearing that as I am saying it. So that's where m is the slope and b is the y-intercept, basic. Exponential, we did a lot of those. That's where you have y equals a times r to the x. So let's talk about a couple things about that just to remember. If it's going to be exponential, x has to be the exponent. This stands for the first term in the sequence, and that stands for your common ratio, okay? The quadratic, you've heard me say this a couple of times in the past week or so. The basic form of a quadratic is y equals ax squared plus bx plus c. So it has to be in that form where your highest exponent is an exponent of 2. Sometimes you have 3 terms, sometimes you only have 2 terms, but this is like the basic formula for that. So what I have here are 3 examples of equations, and we're going to decide which type of function each one of these equations would be. So for letter A, I have y equals 4 times 3 to the x. So here's what I'm going to look at. I do have an exponent, which is important, but the exponent has to be x in order for this to be exponential. So that's a key feature right there. B, y equals 3x squared plus 16x plus 5. This falls into the pattern of our quadratic function. So this would be a quadratic. And then C, that looks pretty much like y equals mx plus b, where 5 is the slope and -4 is your y-intercept. So this would be linear. Okay, now your assignment for today, I think there's 9 questions, maybe 8, but I think there's 9 questions. It's going to be multiple choice. You're going to have some tables and some equations, and you're going to choose, is it quadratic, linear, exponential, or neither. Canvas should score that right away, and there's a second attempt that you can go into right away. I will be Zooming, so please come into the Zoom session at 11 o'clock. I would love to see your face and hear your voices and help you out if you need some help. I will talk to you later. Thanks. Bye.